This is a little bit smaller, but if I'm working with four-year-olds and 5-year-olds, what I would do is I would make this grid big enough that I could get 3 4-year-olds standing in one of these squares, which right now that is my 4-year-olds is the little pup. And I'd start out by telling a story. And so the story I'll say is there is a plot of land that a monster can see, and there are aliens that pop up in his land. And I like using manipulatives. The smaller the kid, the bigger the manipulatives. When it's really small kids, I kind of like using the small kids as the manipulatives. And so I put one kid in one square, and you are an alien, and you are an alien, and we'll have a pile of kid aliens over here, which we can make this with tape on a playground. If it's dirt, we can just scratch with our foot to make it. String, chalk on the sidewalk. Over here, there's a monster, and this monster has a foot that's shaped like this. So kids, what do you do if you're a monster and there are aliens in your garden patch? So anyone have an idea? What would your 5-year-olds do if you told them that you had a foot and you had a garden patch and it had aliens in it?
You would try to catch them.
And how would you catch them?
You want to catch them.
And so hopefully what's going to happen is a little aliens, ooh, monster, which could change the story. Somebody will say, step on the alien. So let's step on the aliens. So what happens when they stomp their foot down? Boom. And so I can make a frame out of a piece of cardboard or out of something. Well, each time the monster steps, what happens is aliens hear it and they come up to the places where they heard the monster step. Aliens are kind of social creatures, and they like sort of talking, and when two aliens get together, they go, hey, let's talk, and they go party. So I don't know if things got better or worse. We had 2 aliens, now we have 4 aliens, but we've got our foot and we can stomp. So where might we stomp next? Which we could stomp where we were or stomp somewhere different. And so it's a little difficult to say over the phone like this, but if somebody wants to shout out, when we go in and do it to for an older group, it'll be easier to interact. So first of all, do you like the foot pointed with the big toe away from me, to the left, to the right, or towards me? And so somebody introduce themselves, say their name, and tell me which direction you want the toe to point. And if nobody shouts out a toe direction, then Josh will call on somebody and say, hey, you, tell me where is your toe pointing?
This is Stephanie Hansen from Page. Can you like turn it 90 degrees and have the toe pointing to your other way?
Other way, like that, okay.
Yep.
And then if we set it down, do you want it on this end? Do you want it over here? Do you want it over here?
On the very bottom end.
Like that?
No, other direction, 2 blocks, the other end.
Like that?
Sure.
All right, sure, let's do it. And so here come monsters. And you can imagine directing kids to run into the squares and hopefully they start getting into this and then these two go apart. And so now we need to step again. So, thank you, Stephanie from Page. So, where do we want to point the toe now? Do we want to point it away from me? Do we want to point it towards me? To one of my sides?
Hi, my name is Henrietta Bubernack. I'm from Albuquerque, New Mexico. I would point the toe toward you, but
Okay.
all the way to the far squares.
Like here.
Yes.
Ah, and we're gonna start, does anybody see a shortcut to this? I'm putting in coffee cups like this. And then removing the pairs.
Not that one.
Oh, wait. Oh, that wasn't covered. Was it? Is that, did I cover?
Yep,
it?
you're good.
Like that. Okay, groovy. So now what might we try?
Hi, Dave. This is Virgilin from Winter Rock. Do that corner by you, near you on top,
Like that?
the other way, the other way.
The
Turn it
other-
around the other way,
Like
where the, yeah, like that. Yes.
this way?
You could do that way or the one nearest you. Either
Oh.
one.
Sure,
That's fine.
that's fine. All right. Does anybody see a shortcut? Do I really need to put the cup here and a cup here and then remove those? Or could I do it fast? You see what's gonna happen when I step on this? This helps keep track. I think with the little kids, actually having them follow this idea where new aliens come up into every step is probably a good way to do it, is break it in steps. Some of them might see that if there's already something there, it's gonna disappear. But we've got that. We've got it going on a little bit. So is there another place we can step? So what are our thoughts?
I was like, also it's not.
Dave, this is Kelly Shoemaker from South Dakota.
Hi, welcome.
Hi. Could you put the foot over the top cup and the bottom feet, turn it 90 degrees to your, would it be your left?
Like this.
What I'd like to do is capture, now turn it 180 degrees. So you capture the top cup with the foot and the other two on the side.
Oh, so you want to capture like this?
There you go. Yep, perfect.
All right. So Erdos said that mathematicians are a machine that converts coffee into theorems. And so, of course, we have coffee cups at a math. We're down to two, which is kind of good. We started with like one here and one there. We've moved them closer together. It looks like we're making some progress. So now what?
This is Anna from Page. Are you, hey Dave, are you able to capture them both? So, and somehow, yeah, just like that. But then you're still left with two, so
Right. Well,
I'm stuck there.
You know, we didn't do the math circle salute, but the math circle salute would tell us if we could think backwards, that would be a useful thing. And so what we really need is something where maybe we capture one and add three so that we are in total getting four, but get four in a configuration that looks like this. Our very last step, we had one here and one here, step on them and kill them all. And so that's kind of what we're looking at. Is there a way to arrange it? That would give us something that looks like that. You know, if we did it like that, we get something that would look kind of like an L shape. If I want to capture two and leave, you know, that kind of gives us the same configuration we had over here, just different height. Maybe there was a different way to do that. So, thoughts? What's the poison? I'm really happy that you guys are responding. That's difficult at 9 and 40. You might not have had off.
It's 8 here, but
Yeah.
it's early. Maybe undo what I did.
Maybe undo what you did. All
Okay.
right. Just to be fun, I'll undo it on the other side. How about that? Yeah. So what would be really nice is if we could set up something where we get the same picture again. And so, whoops. You know. And so what kind of configurations can we get as we move this around and fiddle with it a little bit? That's just going to move it over to the hair. Seem so useful. Not so close. That would put.
Okay,
arrow-
I have a question, but this is Joycetta from Kienta Middle School. But when the students are playing this game, you said they're playing with their bodies, right?
So I was doing this with a group of 4 or 5-year-olds. I would want to help, want to be more than just me. I want to have myself and another teaching assistant at least. And I'd like to make these squares like the kind of squares you get when you play Foursquare, about that big. And then I can have 2 kids run off to the side like a playground game and stand in the square. And then I'd have piece of cardboard or maybe some ropes tied together that we could use to go, it stepped on you, you know, to try to make it even more of a sort of game outside. And can we kill the aliens or make them go away? If we don't use the word kill, let's send them all to the party. Which, you know, I've taken things like I went out painting wells and I did the river. You know, you may have seen me do river crossing with tablecloths where I'll write the pattern on a plastic tablecloth so I can just unroll it and put it on the ground and then start playing. Somehow, the more they can embody themselves, the easier it is to do, the less abstracting. Even at this size, this is probably pretty good for a first or second grader where they've got manipulatives. It's big enough. It's not difficult to manipulate with their hands. but it's not thinking about it abstractly. Like if I had this on a piece of paper, there's things that they can touch and feel and link.
Yeah.
And so, yes. And
Okay.
you know this better than I do, actually. You're the people that work with kids more often. I tend to work with college students, which also kind of like getting out and playing, not all the time. You know, it's just try, you know. In fact, one of the things you can do is often when people don't know an answer to a math question, they just don't do any. It's kind of a natural thing. Well, I don't know. But, you know, I didn't, you know, nobody chopped off my arm. I didn't get hit because I do some move. You can just fiddle as you talk. You know, you can be eating, and then lo and behold, here comes the answer. Right? Your subconscious mind can maybe help and solve for you a problem that you don't see how to do on your own. Right? You just, this is an important thing. Guessing. Sometimes teachers will tell students not to guess when you're doing. You should always guess what's going to happen. There's no bad costing. You might suddenly have an insight that tells you exactly what happens and the way it's going to work. You know, I think one of the problems we might have been having as I'm sort of fidgeting with this is that our cups maybe were too close to the corners and we didn't have enough wiggle room to try to get the strategy to get 4 together. Now maybe we are getting closer. You know, I don't think 2 on the edge was very good. We kind of blinked between there and there. So, you know, if we see a place and we kill 2 at a corner, and that would kill 3, and that'd give us 2 here. Right? We can just try it. Which hopefully you see at this point that these 3 are going to die. Another one's going to come. I'm not sure I would do that with the small kids unless a kid discovered. Then I would really praise and see what we could do. So let's see. Put this. That's going to kill these 2 and put 2 over here. And now let's think about it. Can we make a footprint size thing somehow by maybe killing one of these? I'm not sure I like the language kill. Keeping one and filling in the rest. So I don't want to kill 2, but I do that. If I do that, killing 2. If I do that, what do we think?
Hi, Dave. This is Virgilin. The NSP, I have a question for you. Somebody put in the chat, what are the instructions of the game? I'm sitting here thinking too, what is the objective? What do we want to do? Do you have a printout of that also for us? Thank you.
So after the session, I'm going to print the rules, and I've got some fancy things that can print it out, doing for different age groups and pictures of this plus the video. Here I'm following an idea of somebody who I really respect, who's Gordon Hamilton. And so Gord describes that when working with children, even middle school and under, often a nicer thing to do than to give them the rules up front is to just start playing and let them guess. And then if they do something wrong, you go, no, 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 that's not the rule. His point is that too often an instructor will walk into the classroom and they want to lay everything out about what the rules of the game are. and the kids start fidgeting and they start getting bored, and you start losing the attention, the excitement that you might have at the beginning of the program. And even if you spell out all of the rules and then start playing, the kids might start forgetting the rules, and you might have to remind them and do it anyway. And so his point is that if you've got something that has rules, get them started in the activity, let them go. He has another point about this pedagogy, and that is when you're really trying to invent something and create something new, like I'm here in a research institute, there's no rules for how to do the research. We're trying to discover it. Nobody's going to tell you explicit directions. But this said, when somebody's explicitly asking, what is the goal? Our goal is the monster wants to get rid of all of the aliens in the garden path. And this is his garden. Oh no, it's got 2 aliens in it. And the way the monster does it, the monster stomps on the aliens. And if you say a foot in aliens, some kid is hopefully going to say stomp on the aliens. And so there you've generated by the story the fact that they get the first rule. I don't have, Gord might take it as far as just demonstrating what happens. When they stomp, new aliens come. And then, hi, my name is Frank. I'm Joe. Hey, what are you doing? Let's go play. And so then hopefully the students get an idea, and look at this. Where did we end up? Just as we're sort of talking, you see where we want to step now?
Mm-hmm.
Boom. And more aliens come up. And hey, Joes, let's go. Let's go party now. Everybody's learning the alien Stomp game. And so that is Stomp. This monster completely cleared his garden patch. Okay. So I think what I'm going to do here.
Dave, this is Henry.
Hey, Henry.
Put the cups back to how it was, the 2. The previous cup, no, how it was before you killed the monster.
Before I killed.
Yeah, where your foot is at, right there, that diagonal, the other way. Clear the, yeah, the original, where your foot diagonal to your left. Yeah, right there, and take those off, yes. And now take your template and cover the other direction to where your knee's at.
Like,
yeah, up to the other, up, rotate it 90, yeah, the other way. For your foot and then your knee. The other way, towards your, yeah, flip it now, flip it.
oh, like this.
Like that, yes, that's another way to do it too.
Very, very good. Woo-hoo! So we say this is the Henry Stomp, not a new dance. And I like naming observations after the person that makes them. Give people credit. Hopefully that gets them more engaged. Yeah, so there's the Henry Stomp, and here is the final Stomp. And everybody goes in first. So now I'm going to turn off the cell phone, or my student Josh's. I'm going to come sit screen and do a screen share. Unmute here. And take a second. And so Screen share, screen one. So, and let me hide these meeting controls. Oh, let me get this out of the way. So, will you see, and I believe you do, something that says alien yard, and it's got an alien sitting over here as the starting place, and it's got a foot. This time the foot is a different shape. It's the same rules. Now, I'm doing this with a program that is called Inkscape, which is free. I will put a link to where you can download it on the website afterwards. And in fact, I'll put this particular file on. I have also made PDFs of these. If we are working with fourth graders, what I would do is I would print the PDF of this on a printer. I would cut it down here. I would take this and I would put it in copy machine and copy it on a transparency and cut out the frame so that it was semi-transparent, which this particular frame is transparent electronically. The reason that I would do that is so that I could lay several of these out on a table. If I had 20 students, I might lay 4 of these out, and then I'd group the students in groups of 5 and let them play. And I'd have like little, you could use pebbles or beans, which I often use if I've done this activity in festivals there in the Navajo Nation many times. I'll use ghost stones, but I like having it out on a table where again you can touch and feel. Go to a dollar store and get little toy aliens, whatever. By the way, if you look at this and say, yeah, I think I could do this activity, why not join our mentoring program and talk to me, make sure you answer questions, get printouts and do it and get paid for it. So the electronic version, well, if we're COVID and we have to, we can make it work. Let's make this work. So I can rotate this foot in different directions by hitting the rotate direction. I guess we can talk about the corner of the foot. We want the corner of the foot pointing to the lower right, to the lower left, to the upper left, to the upper right. Anybody ever thought where they want that corner pointing? So hi, Clorinda. I see you're asking to miss. So I was demonstrating the same activity. This activity is called Stomp. And the story behind it is you are a monster and your foot is shaped like this. You have a garden that's shaped like this, and aliens pop up in your garden. And so being a monster, you see things, you decide you're going to stomp on them. And so now we're going to stomp on the alien. And so Clorinda, since you caught my attention in the chat, where do you want this corner? Which direction do you want to face your foot? Do you want it upper right? Do you want it lower right? Which direction should we point that corner? Oh, I'm sorry. I had my, let's try that again. I had my sound off. Was somebody talking? Can someone say hi at least so I know that my tech is working?
Hi, David. This is Kelly Shoemaker again. So
Hi.
what I was wondering, and I would like to put that foot, if you call that the foot, in the upper left-hand corner.
Okay.
But I was actually I would when you had it over there before, could we make it could we put that could we put the empty spot in the bottom right hand.
Empty in the bottom right. Sure, yeah. So I'll just rotate, which
Okay.
notice the way I'm using the controls. You'll be able to use the same
Right.
program if you want to do it like this on the screen.
And then if we could put that in the bottom right hand corner of to cover the alien
Sure.
there.
So,
What I was wondering, when you were thinking about, you didn't want to say, kill the aliens, if that would be touchy for some kids. What if you also on the alien yard had their spaceship, a picture of their spaceship, and if they got caught in the garden, they would have to get beamed back to their spaceship and then start all over. So that would kind of, be the same thing, but a little easier, maybe.
sure. Absolutely, and it doesn't have to be aliens and monsters. It can be whatever is culturally appropriate, whatever you want. And this is a kind of thing that if you decided to do this mentor and you said, hey, can you change the graphics on this? I don't want aliens. I want this coyote and you tell me what you want, and we can try to work, or you can make your own as well.
Gotcha.
Sure. So we just stomped and now we have 2 instead of 1, which is kind of interesting because we changed the parity. And so I hope, Clorinda, that this answered what you missed. I did this first in the floor where I made a big grid where I like doing it from persons. Anna said, building thinking classrooms recommends quick instructions verbally to get the students thinking. Yeah, the points are we want to get the students doing as soon as we can. Gabriella put Gord's website on, which has just a lot of brilliant advice and sessions and videos of him actually doing this with students from all around the world. So let's see if we can knock this one out. Does somebody want to give another suggestion of where to stomp? So you want to kill 1 and produce 2, so you have 3. And so can you put this so that it would cover just 1 of them? So, if I stick it here, it covers 2. So I do it like that. It's kind of hard. And so if we wanted to just cover 1 of them, is this a good orientation or what should we do? I hear somebody tapping their mic.
This is Joycetta from Kienta Middle School. You can turn it like an L.
Like that. All right. Now can we cover 1?
And go up 1.
Up 1 like that.
And then to the right. Right there.
If I do that, we'll get 3 in a row. Would doing 3 in a row solve it for us? It at least gives us 3, which is interesting. Is there somewhere else where we could kill 1 and end up with 3?
If we drop it 1 space lower than that right there.
Yeah. And then paste. After I copy the aliens, I can just hit the Control V for paste. And now here are 2 aliens that I send off to the alien party. The alien party looks kind of reserved. They're all there in row, but sure. Now do we see where the monster's going to step next?
Hi, this is Ty. I'm from Sawmill, Arizona area, and I'm calling in from New York. It's pretty obvious. You have it already set up.
Awesome. I'm glad you're joining us. It's nice to meet new people. So, I can add three, certainly by the time your fourth, fifth graders are going to start to recognize and start making shortcuts that they don't need to add, and then take away. They'll just say, all right, missing. Cool. Let's try another one. So do we want, well, we've got some time. I'm debating. Maybe we'll come back to this one. Let's look at this one. This one's kind of interesting. Has a slightly different feature. And so I think this puzzle is appropriate for all ages. If you're doing high school students and you didn't want to make the manipulatives, you could probably print this out on transparencies or have them have pencils and erasers and make a grid where they could put little marks if you didn't have any counters, and they could do it just with paper and pencil, though the manipulatives make it kind of more fun. So what do we want to try on this? I'll tell you what. If nobody volunteers, I will pick people.
You could make it vertical and then put it in between the two aliens at the top of the square. Or, yeah.
Okay. I might have just rotated something somewhere else in the document when I clicked. So like there's where you wanted it?
One more to the right.
All right. And so then I'd put two here, which would disappear, and one would move here. So I can just slide him up to here.
Yeah.
Right? Okay. So now what?
Same thing with the bottom.
Same thing with the bottom. And so just here. And now we'll get two new aliens, one appearing here and one appearing here. Okay. So now what? Now how many aliens do we have?
7.
So I don't know if I want to add text to this. We had 5. Now 7.
Dave, this is Henry.
Hey, Henry.
I'm in Chicago, so I need to leave to catch my flight home now.
Oh, wow. Have a good flight.
Yeah, I just want to acknowledge all the participants this morning. Thank you for joining us, playing this marvelous games. So we appreciate your presence, everybody. Thank you for what you do.
Yeah.
You can turn it horizontally.
Okay.
And then put it in the bottom or the upper left-hand corner.
Upper left. Yeah.
Yeah.
All right. So that one's gone. That one's gone. And in the text. Now, oops. Now 5. So now what?
Same thing with the bottom.
Sure. Seems like that's going to be making progress for us. So these two aliens go away. And now, lo and behold, we are 3. So now what? Oops. Oh, come on.
I think you can go to the middle space all the way to the right.
Right there. Okay.
And then you can rotate around the middle alien for the last 3. Or do like a,
All right. So let's see. Oh, oops. I rotated the alien, not the foot.
yeah.
Twist the foot. Then like that.
Yeah.
And then there and there. So we were 5, now 3. Now you want to rotate again?
Yep.
Now here.
Mm-hmm. The alien just
That
comes
goes
over.
Yeah, it goes over. All right. Now rotate or slide.
Another rotation.
Another rotation. And we'd add to each of these, and then he'd party, it would party, it would party. Oh, now we're down to 1.
That is an odd.
Oh, well, it's odd as in strange. What are we thinking at this point?
Think we have a problem.
Think we have a problem. Yeah. Why do we have a problem?
There's only 1 alien in 2 spots. That remove them.
Can we be more clear about why? And so it seems like we've got these numbers 5, 7, 5, 3, 1, and we notice that it's odd. Okay, so why does that tell us that we can't get the 0? Odd.
Because the foot is 2 spots and it requires 2 aliens in each box to disappear.
Well, do I need 2 aliens in each box? Let's do just some things. I could put the foot here, and to make the aliens go, I need to put 2 in this box and 2 in this box, is what you meant.
Correct.
Do I need to have aliens in both boxes in order to place it? It seems like I have no aliens here, no aliens here. I could put 1 in each. So when I do that, what happens to my alien count if there's no aliens to begin with? Right. So if there are no aliens under the foot, what happens to the number of aliens when I stomp?
We still get odd numbers of aliens.
Because when I did, so right now there's 3 aliens. If I stomp here, how many aliens would there be?
There would still be 5, and that's an odd number.
There'd be 5. So it changes from 3 to 5, right? So I want to really force people to spell this out, right? If the foot is empty, then it adds 2 more aliens. Right? Of course, the foot doesn't have to be empty. What else could happen with the foot?
We could keep stomping and creating more aliens until we get to a greatest common factor.
So I could make 2 more, I could make 2 more, I could make 2 more. Do I have to stomp where it's just an empty stomp? How many? how
No.
many
So like if you move that green box to the left and then
Yeah.
eliminate the bottom alien and then add an alien to the top.
Sure. So let's describe this. If the foot hits 1, it removes 1
But
and
it gives you
adds
that one.
1, so the number stays the same. Does that make sense?
Yeah.
Right? When we do this, what ends up happening is this alien gets stomped away and another one appears here, and so it doesn't happen. But if the number stays the same, if it starts out odd, it's still odd because it didn't change. The only other possibility, let's stomp again, is the foot could stomp on 2. And what happens if you stomp on 2?
It eliminates both of the alien.
Right. But now, to summarize, we can add 2, we can no change, or we can subtract 2. And so if you start with an odd number and you can only add 2, not change it or subtract 2, so can't do this one. All right. So some points about this. It is difficult to get people to enunciate all the reasons of why things work, but math really has this feature where you can explain every little detail. It all comes out where once you have a problem and you have an answer we can know for sure. It's not something where we're not, it's not complicated like politics or economics or relationships. It's very clean cut. It can have very clean cut answers, and it's very useful to get people to understand how to make these arguments. So this is one of the goals when you're teaching math. And so not just stopping when they say, I think it can't be done, but adding this extra layer of detail. Let's get the students a bit older for the next example. And I'll change this down to a lower. Size. So now we have another board, and let's see, I started at 9:15. We're certainly going to take a break at 10:30. We may need to stretch now to think, but this is a harder problem. But just like any math, what's the first thing you should do?
Analyze.
analyze. How do we analyze? So how do we start thinking about these aliens and this monster foot?
Are there any rules we need to follow?
So the rules that we've discovered are that the monster wants to get rid of the aliens, and the monster has a foot, and this is the monster's garden. So what the monster will do is go and stomp on an alien. Go away. Boom. And whenever the monster stomps on an alien, what happens is everywhere underneath the monster foot, more aliens pop up. But the aliens kind of really like deep conversations. When two aliens are in the same location, they go back to the party and continue talking. And the goal is to get rid of all the aliens. Notice in terms of parity, we started with 2, now we have 3. And this foot has 3, so it doesn't seem like a parity argument's going to tell us that this could happen. In this case, it wouldn't be a parity, which is what you would get if you took the remainder when you divide it by 2, right? If you take 4 divided by 2, it goes in 2 times and has 0 remainder. If you take 5 and you divide by 2, it would go in twice, 4 with the remainder of 1. In this case, maybe you're thinking of remainder if you divide by 3, but wait, if remainder divide by 3, I've got 3. 3 goes in once, remainder 0. So that remainder argument that we had in the prior problem isn't going to say something. Right, and so Imelda said, recognize that we start with 2 aliens and the foot has 3 toes. That's a great observation. Woo-hoo! Imelda found something cool, right? Maybe the size of the yard plays a role in it. Certainly, right? If the yard has only a 2-by-1 yard, the monster's not going to be able to do anything with a 1-by-3 foot because the foot would not fit inside the yard. Which, by the way, when I did that, that kind of seems like a ridiculous thing to talk about the yard with a 2-by-1 yard and a 3-by-1 foot. But as a mathematician, I think of the extreme small cases. It's certainly easier to think of it as small. So thanks, Henrietta.
So
So do
here
we
we have a 3-by-10. So 30 divided by 3. There's no remainders, but going across, it's 10. 10 divided by 3, you will have a remainder. So it would be hard to eliminate across.
We didn't have these questions yet, like when we had the 3 and the 2-by-4, it worked. I think people are suspecting that this might not be possible. I don't know. Is that a guess? Is that a feeling that we're getting?
I didn't realize it until now. I now want to go back and look at the other grid and count the grid in.
Yeah.
So that's kind of what I was talking about, Dave, about the what are our rules for the game. Are you able, because the kids will ask this, especially my high school kids, can you orientate your foot in a way that's not like that? Because if you can, then they would hurry up and try to get everybody over in a group and then reorientate their foot. But so for the first analysis, if you wait for the kids to say, the kids are going to want to know, hey, what are my rules and boundaries? Yeah, like that.
Yeah.
So if we weren't able to orientate it, then that would change our thinking a little bit too, like we were talking about the remainders.
Right. And so, in fact, let me make 2 different points. It's nice to analyze one specific set of rules and not change the rules in the middle of the game. But, let me type these things in here. it is nice to analyze one set of rules and not, oops. While however, it's also really interesting to change the rules and come up with different games. And so, and this is really kind of critical to why we do this, is we want people to be able to invent new stuff. If you hear these stories where some inventor was just said, hey, I'm going to do something different that wasn't with the culture, wasn't with what people were doing. And lo and behold, they rolled up a waffle and stuck ice cream in it. And people are like, hey, ice cream cone, I like that. It's not the usual way to eat a waffle, but yeah, let's do it, right? Also, change the rules. Right? So we don't want to turn that part of our students off. We want to keep them. And so part of this is we can scale this, right? When I was starting with my 4 and 5 year olds, I was using a 4x4 board. If your high school students want to work on a 20x20 board or a 20x21 board, by all means. If they want to work on a board that's not rectangles, if they want to work on a board that's triangles, all of these start becoming interesting questions if you can get it so that your students are making up their own puzzles and solving them for fun. Just imagine and wow. Right? That's a big challenge. That's a big ask to get kids to do math. But you actually see this with, there are various games like we've seen 24, games that have taken off on cell phones and, Wordle. How many kids are playing Wordle? Right? We can certainly see some of these things where people will get hooked on it and start playing with Sudoku, Wordle, and then they're really doing mathematical and thinking exercises for fun, and you're going to get so much more out of that than if you just play. I didn't catch who made that last comment here. So Steph said have part of the foot off the garden spaces, look at the size of the yard. I didn't catch the gentleman's name who was talking to me, asking about rules. I suggested if they could switch the orientation, you could move all of the aliens to one side. I've been sort of subconsciously trying to do that. Is this what you meant? Kind of when I see an alien over to the right, if I take the foot and I move it like that, we can get rid of this alien on the right. And okay, sure, it might make more to the left. Do we see that we can always shift aliens and move them over in that direction by our stomping?
Yeah, so there's a lot of kids in my country that are pretty rural, so they would probably like to herd them all in a corner and get rid of them all at the same time.
Awesome. I love it. Herding me works really, really well. Yeah, that's exactly what we're doing here. So this one's going to disappear and 2 more appear. So we've now herded them all together. So now what?
I would want to reorientate my foot.
Sure. Like here. Or here, or here.
I might have waited one more time to orientate before I put that, but now that we're here, yeah, either or.
Gone. Gone. But no one appears here. Now they're not all into this corner yet, but so we've been at this for a little more than an hour. I don't want to take us too long on the puzzle. Does anybody have any conjecture or guess about this particular setup? Do you think it's possible? So Anna's worried about them being at the diagonal. So, yeah. No, they're not on a diagonal. So I'm going to do something because I want to point out how this can become much more sophisticated. So I'm going to take just a second and go above, and then we'll take a break and stretch, and then discuss, and then, after half an hour, move on to the next topic. It turns out that this puzzle is not solvable. As I started with one in this corner and one in this corner. But the argument to say that it's not solvable is not just a parity argument, or it's not just a reducing mod 3 argument where you take the remainder divided by 3. The argument is going to be, let's take this guy. So there's sort of a magical argument that comes out of the middle of nowhere. And then there's an argument that comes out of tools that you have to teach in maybe 8th grade, most likely in high school. So here I've made a really funny way to color the 3x10 grid, 10 going across, 3 going up and down. And I want you to make, notice and wonder. Tell me what you notice about if I stick the foot there. I'll lift it up. Any patterns you notice if I put the foot in this position or in this position? Any patterns, anything you notice about this colored grid? So, Marilyn Young, welcome. It's nice to meet you. Are you there? I'm calling on somebody. Surprise. You can unmute or type in the chat. Do you notice anything about my colored grid? Yeah, I'm going to do complete spoiler alerts because we're running short on time.
Probably the colors are even.
Colors are even. What do you mean the colors are even?
Like green, there's 4 green on the top, and then there's kind of like 4 bands of blue.
Uh-huh. And so there's green and blue. What else do we see?
The pattern changes every time, every 3.
Bottom
Blocks.
changes every 3. It repeats every 3.
Yeah.
That's kind of interesting, right? It's got this threefold periodicity. Right? You see this pattern here, and then it repeats. Is it just the bottom that repeats every 3?
No, the whole vertical.
The whole thing repeats every 3. Yeah. And we notice that there's green, red, and blue. And I've cut all of my squares into a pair of triangles. So we could look at upper triangles, or we could look at lower triangles. So let's look at just the upper triangles for a second. So if we looked at the upper triangles in this column, what colors do I have? Here, what color?
Green,
Here,
Red and blue.
Red,
and
blue,
sure, so I have green, red, and blue. What do I have in this column?
Red, blue, green.
What do I have in this column?
Blue.
Green, red.
red.
Is there any, so what do you notice about every column when I look at the colors in the upper triangle of each square?
Two of the same color.
I have a red, I've got a blue, I've got a green. I've got a blue, a green, a red. In each column, I have each color. And so when I put this thing over here, you notice it covers an upper red, an upper blue, and an upper green. So it hits one of each. If we orient it in the other direction, and so if we go sideways, if I go here, what color in the upper do I have versus here versus here? I've got green, red,
blue.
blue. Here I've got red, blue, green. Here I've got blue, green, red. No matter how we place this thing, it's going to cover one color each in each of the upper things. Yes? Also, if we look at the lower ones, it seems like the same pattern's happening. Green, blue, red. Blue, red, green. If I go down on the lower triangles, green, blue, red. It's always covering one of each color on either the top triangle or on the bottom triangle. So that means that when we put this in, it's going to increase the green by 1 or decrease it by 1, increase the red by 1 or decrease it by 1, increase the blue by 1 or decrease the blue by 1, if I'm counting how many aliens we see on these squares, which if I make the red go up by 1 and the blue go down by 1, then they've changed by 2. If I make the red go up by 1 and the blue go up by 1, they've stayed the same. But in particular, it can only, the number of colors you see will keep the same parity, both on the upper triangle and the right. And so there's still, but it's a much more complicated parity argument. You might ask, how on earth did I figure out how to color this rectangle in this pattern? And I will show you 2 ways. One way is because this looks like, wow, how did somebody think of that? Here's another version of it. Let's see if I can get down to it. Yeah. Where it's kind of coded, but in different squares. The way I created this is I imagined that we put one alien in this square and then we herded them all into the upper left over here. Well, if I did that, it's already in the upper left. There would just be one alien in that square of this 2x2 block. Same if I started here, same if here, same as here. If I put one alien in this square to begin with, so that it's less abstract, let's just do it. If I started with just one alien in this square, and I herded it into this upper left corner, to herd it, what I'd have to do is I'd have to rotate the foot, and then I'd put the foot here, and when we stomp, this one disappears, and I think I lost my alien, so I'll copy an alien and paste. We would pick up two like that. You see how I did that? And so that means that if one alien starts here, after herding, I would have an alien in the left and an alien in the right here. Somebody's got a movie or a video on their unmuted Zoom. So when we start with an alien here after herding, you would have an alien in this box and an alien in this box. And so that is how this is colored. If I put an alien in this box, I could cover up once herding, putting here, putting one here and one here. Then when I cover again, this would disappear, and we'd be left with just one, which is why it gets back. So in each one of these cells, I show you what's going to be left in this upper 2x2 block after we do all of the herding. And then you can see if you have a configuration where we would have an even number of aliens in each box, then we could finish it. So for instance, if I picked one here and one here, because those both have a single box in the upper left, we could solve the puzzle. So here we would get just a one square count in the upper left and one square count in the upper left. This is solvable because I could put it here, delete, adding another one here and here, and then moving the foot over, and then all of those would disappear. This is in fact how I discovered this coloring pattern. Is I translated this into colors. I'll put some more in the writing. One other comment that I want to make about this that I don't have time to really expand on is I could convert this into systems of several equations and several unknowns. And so I could let a variable talk about how many times I stomp horizontally with this this first cell as the first stomp. I could talk about how many times I stomp going here horizontally, how many times I stomp across here, and then I get equations for in this cell. If I had one alien here, that one alien would have to be covered by a certain number of stomps with a piece put here and a certain number of pieces here, and then vertical ones covered across, and the total number. So this can be converted into systems of linear equations and linear unknowns, which may be surprising. Like, 2x plus 4y equals 7, and 3x minus 5y equals 9. Right. So some of you, if you're teaching college algebra, may be talking to your students about solving systems of equations like this, and you'll see examples where you're mixing nuts. This could be an example that you could show them is a tiling problem where the solution is going to turn into solving the systems of equations and unknowns, which is something that they would think they would see is very, very different than what they were expecting. If you want to know more about this and bring something like this to high school students, let me know. With this said, I've been at it for an hour and 18 minutes. I'm going to suggest that everybody get out, stretch. Let's take a 10-minute break.